In this lesson, we are looking at an introduction to graphs of quadratic equations. And a quadratic equation is a function that can be written in the form y is equals to ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be 0. But why can't a be 0? Because if I plugged in 0 for the coefficient of x squared, then I'm just left with a linear function. So here are some examples of quadratic functions. So now the graph of a quadratic function is U-shaped, and this is called a parabola. The maximum or minimum point is called the vertex. And here, let's look at some examples. Identify the vertex of each graph, and then tell whether it's maximum or minimum. Okay, so let's do this. And here, I see the vertex is at negative, actually not -1, but +1 and -2. And I can see it's all the way low, so it's minimum. Then I go to the next one. I see the vertex is at this point, and that point is -2, 4, -2, 4, and this is a maximum because the highest point. And here, let's look at some key features of a parabola. And what I would want you to do is to graph this on Desmos or a graphing calculator. And see, I've given you a pair or 3 of them, like in the second example here. So you graph them and then see what is happening, these 2 pairs. And you can pause the video and do that. And once you are done, this is something you noticed. Here, a is equals to -3. Here, a is equals to +3. When a is greater than 0, meaning it is positive, the parabola opens up. When a is less than 0, the parabola opens down. And one way you can remember, see, when a is positive, the parabola behaves like a happy face. So happy, it's positive. When it's less than 0, it's negative, so it's going to be a sad face, so opens down. Let's go to the next example here, and I see here a is equals to 1, this is equal to half, and the next one is equals to 3. And what you noticed is when a is less than 1, the parabola is vertically shrunk. And I can also say here, if I compare the shape, it's going to be wider. And when a is greater than, is equals to 1, this is just going to be the same width as the parent function, x squared. And when a is greater than 0, greater than 1, we can see it is vertically stretched. And we can also say here it's narrower. It's narrower. Okay, now let's move on. So here, the highest or lowest point of a parabola is called the vertex, which is on the axis of symmetry. I want us to remember that axis of symmetry. To find the vertex, substitute in x is equals to -2b. So this is a formula here which we need to remember, and I want you to pay attention to the axis of symmetry. So here, when we do Let's do an example here. Suppose I have x squared minus 2x plus 1, and I'm told to find the vertex. So I'm finding the vertex. So how do I do that? I'm just going to use my equation. But before I use my equation, I need to know what my a value is from my equation. So see, remember this is, let me just write it as y is equals to. So a is equals to 1, b is equals to -2, and c is equals to 1. So now I can be able to get x is equals to, remember the formula, minus b over 2a. So this is going to be minus -2 over 2 times 1. So, and that will give me positive 1. So x is positive 1. Now what I'm going to do, I'm going to plug that into the equation. So y is equals to 1 squared minus 2, and this is times 1 plus 1. And what do I get? So I get 1 minus 2 plus 1, and that's going to give me 0. So that means the vertex is going to be at 1, 0. So that's how to find the vertex. And so here we find the value of x, then we plug it into the given equation. Then that's going to help us to find the y value at the vertex. Now moving on, so let's talk about the axis of symmetry. So, and the axis of symmetry is given by, this is the vertical line. The axis of symmetry is the vertical line that passes through the vertex, and this is the equation. Note that this is the equation we just used on the previous page. So if I'm using the same equation, y is equals to x squared minus 2x plus 1. So the axis of symmetry, and I'm going to call this AOS. That way I don't have to keep writing the whole thing. So the axis of symmetry is going to be minus b over 2a, which is equals to minus -2 times 1, which is going to be positive 1. So the equation is going to be x is equals to 1. So that is the axis of symmetry. And the axis of symmetry, if we want to visualize it, so if this is the vertex, it's the line where the graph is going to be passing through. So this is the axis of symmetry. It divides the graph into 2 equal portions. Now let's look at x-intercepts, and these are the points. These are the 0, 1, or 2 points where the graph crosses the x-axis. And for example, if I have a graph, I just make a sketch here, and then I just want to show you what the x-intercepts are. Suppose I have my parabola there. My x-intercepts are these points. Wherever the graph passes, cuts the x-axis. If I was given an equation, how do I solve for it? If I'm given an equation, let's say negative x squared minus 2x plus 1, and I'm told to find the x-intercepts for this, all I would have to do is equate this to 0 and then solve this equation. And we're not going to do this at this point. Okay, now let's go to the y-intercept. And this is where the graph cuts. This is where the graph cuts the y-axis. For example, if I have a graph, let's assume I have a graph, and I'm just making a sketch. If that's my parabola, this here is my intercept, y-intercept. And how do I, suppose I'm given an equation, and I'm just going to use the same equation here, minus 2x plus 1, and I'm told to find the y-intercept. All I need to do is to say x is equal to 0, and then y is going to be 0 squared minus 2 times 0 plus 1. So the intercept is going to be 1. So y-intercept is equals to 1. Okay, now so here, without graphing the quadratic function, complete the requested information. So these are some examples just to deepen our understanding. So here is equals to 3. So how is this graph going to open? So it's 3, it's positive. So it's going to be a happy face, it's going to open up. So that if it's opening up, the vertex is going to be at the lowest point, which is the minimum. Is it going to be wider or narrower? Remember, because it's going to be vertically stretched. So this is vertical stretch. So that means it's going to be narrow. It's going to be narrower. Okay, now we have another one here. So A is equals to 2/3. And if A is equals to 2/3, that means it's going to be opening up. The vertex is going to be minimum. It's vertically shrunk. So vertical shrink, and it's vertically shrunk. That means it's going to be wider than the parent function. Remember, the parent function is this one right here. Y is equals to x squared. That's what we are comparing it with. Okay, now we go to the next page, and that is the introduction, and we shall move on to the graphing on the next video.